All right, so here we are talking about sorting out lab errors. And there's a whole page of lab errors that you were meant to look at for homework. And we just need to make sure that we can sort of label the final answers on this. You were told to look in the lab style guide to be able to identify what these things are. We had random errors and we had systematic errors, and then something that's not truly an error, a blunder. Blunder is, for lack of a better word, and I don't like to say that it's a screw up, but it really is a screw up, okay? So not being careful enough or something like that. So I want to go through these things, and I'd like you guys to give me some shout outs. Maybe you know what these are. Not being careful enough with calculations or rushing to complete analysis is blunder. I'm going to put B for blunder. Fluctuations in environmental conditions like temperature or humidity.
Random.
Random? Yes.
You can't control that, can you?
No, you can't really. All right. Well, you could try to. You could try and put containment around things, right? Procedural errors in data analysis, like incorrect data collection methods. Systemic, yeah. Or systematic. Human procedural error in measurements, parallax angle, for example. And there's an example of what, or a description of what parallax angle is in the lab guide. What would you call this one? How many people say random? Random. How many people say systematic? The thing is, we could kind of argue both on this one, depending on how you argue it.
Blunder.
So it's not blunder, but random and systematic. It really does depend on how you interpret it. Take a look at the lab guide for explanation on that one, okay? Number 5, imperfect experimental design. Systemic. Systematic, sorry.
You're missing.
Number 6, background noise and data collection, e.g. electrical interference. Random, yeah. Random. Variability in the equipment precision, like instrument calibration. Anybody want to guess? So if we failed to calibrate the equipment, that would be systematic. If the equipment is falling out of alignment because of environmental factors, like vibrating tabletops that we didn't realize was happening, we could argue that it's random. But it really kind of depends on how you're going to argue that one. I would lean more towards systematic on that one, though, okay? Sample selection bias. Systematic, yeah. Sample contamination during handling or preparation. So you haven't thought about contamination, or did the contamination happen because the environment's kind of dirty and you didn't realize?
You didn't follow the rules and contaminated it.
Random. All right. Calibration errors in the equipment. Systematic, because you tried to calibrate it, but you've made an error in somehow the way you've done things. Instrumental drift over time. What does that even mean, instrumental drift? I kind of suggested that there could be environmental factors. Like over time, could a balance slide slowly out of calibration? That would be random. Inaccurate standards used for comparison. Systematic. Instrumental bias. So like having 0 be offset. So when you zero an electronic balance or something like that, maybe there was stuff on that balance that you didn't account for, you should have removed it. Random or systematic? Systematic, yeah. Inconsistent experimental technique among different operators. Could people do things slightly differently? Yeah, it's going to end up being random. Using incorrect equipment to make length measurements, e.g. not being careful. That is a blunder. Instrumental limitations not accounted for by the experiment, or in the experiment. Systematic, yeah. Okay. Now, Some people I think might have noticed this, maybe you didn't. The answers are upside down at the bottom of the page. Show of hands, how many people noticed the answers were upside down at the bottom? You dirty cheaters. Or did you just check your work? I don't know. Check your work, all right. Please make sure you kind of understand why these things are the case. Take a look at that lab guide. There's that QR code that I showed you, but there's also lab guide linked in the online resources, okay? Make sure that you know what's going on there. We should be able to explain how we know that these things are the case, because you're going to have to identify types of errors in upcoming labs.